So we have covered many critical concepts in our courses, including DevSecOps and ruthless automation. If you're leveraging and embracing artificial intelligence and machine learning, there is an additional concept that we shall discuss: ML Ops. So what is ML Ops and why does it matter? Let's get started. MLOps is a set of practices that aims to deploy and maintain machine learning models in production reliably and efficiently. MLOps is leveraging the same principles and concepts around DevOps but applied to machine learning. ML stands for machine learning and Ops for operations, just like the Ops of DevOps. MLOps involves data scientists who create models and machine learning engineers to transition them to production. It's all about removing bottlenecks and automating your model's build and deployment. It's also about ensuring that every aspect of your models are stored in Git. Like DevOps, the objectives are pretty similar. Just like continuous integration, the first objective is about optimizing flow and enabling rapid experimentation and development of models. Just like continuous delivery, the second objective is centered about removing bottlenecks and making your deployment seamless, updating those models in production. And just like DevSecOps, the third objective is focused on security, testing, and quality enforcement. Obviously, to build your models, data is a critical and foundational piece. That data must be organized and cleaned. That is obviously time-consuming. The quality of that initial phase will determine the quality of your model. The more your data increase in quality, the more you have an opportunity to continuously improve your model. It's a compounding result. Just like GitOps, one of the main concepts behind MLOps is to ensure everything is in Git. That includes the versioning of your data and its attributes. Once your data is ready for prime time, keep in mind that it is an iterative process. And it is now time for phase 2, build your model. We're not going to do a deep dive on these in this video, but as part of the build of your model, several decisions have to be made to optimize results, such as selecting the right algorithm, hyperparameter tuning, and feature selection. This is part of your experimentation phase. Obviously, there are vast combinations that come with such decisions, and results will vary based on those, so you must experiment with options to find out which one will be the right fit to your desired outcome. As part of this iteration, you need to learn from your wins, but also from your failures to ensure you're able to take this into account for the next cycle. Just like software is never done, your iterative process on your models won't ever be done either. It's an endless loop. Obviously, as you've seen in our video, fail fast, learn fast, but don't fail twice for the same reasons, you must be able to gather metrics to learn and continuously improve. Those metrics will enable you to see what parameters and attributes are bringing the best results, so you can fail fast and learn fast. Following the GitOps principle again, all that code and configuration parameters will be stored in Git, of course. Just like your DevOps pipeline, ML pipelines enable you to automate this entire process and continuously iterate to save time and ensure that there is no drift in your process. Your model now built, it is time for the next phase. It's validation. You must ensure your model isn't biased due to biased data, for example, and that it meets your desired outcomes. One of the hardest problems to solve with machine learning is around interpretability, explainability, and model bias. This can include behavior analysis of the models and leverage various validation techniques like train and test split, resubstitution, random subsampling, and more. We will cover explainability, model bias, and variance in a separate video. Your release pipeline as part of your continuous delivery can now deploy the model in staging first and then production. Just like with our DevOps pipelines, models can be deployed in containers and run on Kubernetes. Just like any other type of software, your deployment can leverage canary releases, plugin deployments, etc. Once you get to your MVM, minimal viable model, the model can be deployed to start getting real-life feedback in production. As you know, the only way to truly learn and get feedback from your end users is in production, not in a lab. Obviously, while you may have the warm and fuzzy after deploying your model, this is not the end. The next phase will now focus on monitoring, just like DevOps. We will measure latency, performance, but also model drift. Model drift can be caused by many reasons, such as your desired outcome changing and the definition or the data you're leveraging are not representing any longer your current demography. Those can often slowly change until you wake up and realize the model is absolutely incapable of meeting your needs. Many other factors can make your model drift, including changes from your end user standpoint or the seasonality. The retraining of your model is then essential to ensure that you're addressing the drift and update your model continuously, incrementally. Alright, so there are many capabilities that can help you implement MLOps, including cloud provider specific services, but we highly recommend avoiding vendor lock-in to ensure the same cyber stack is deployed across your environments. So deploying the stack on your Kubernetes environment is essential. That's why we recommend Kubeflow, the open source project to provide an end-to-end MLOps solution. Watch our video on why Kubernetes is a must if you have not yet. Just like GitOps and DevSecOps, the automation is key and your entire stack must leverage infrastructure as code, configuration as code to ensure full automated instantiation of your MLOps stack. There you have it. MLOps is the process that enables data scientists and IT engineers to collaborate, remove bottlenecks in the data management, curation, experimentation, development, validation, deployment, and monitoring of your models. MLOps will enable you to scale while enabling reusability and reproducibility while enforcing proper governance. Just like DevOps, MLOps maturity will evolve and your team will continue to learn and optimize their processes. Kubeflow is one of the leading MLOps open source projects that you can leverage on top of Kubernetes to accelerate your MLOps adoption.